right, guys, welcome to week 5. I'm going to go over a concept we've learned before. Everything we're going over, we've learned before. But today might be a little interesting the way I do my lesson because I'm going to do this video and it's going to kind of go along with the Desmos I want you to do after this video. Okay. So if I was going to graph this is kind of intro. If I was going to graph this is a 3, right? This is the first thing we do when we graph. And that's going to tell us on the y-intercept where we're going to put our point. And it's at 3, so we're going to go positive 3. All right, and then what we're going to do here, we're going to go down 5, right, over 3. So really this should be negative 5 over 3, right, instead of the negatives over here always, but I always say the negative goes to the numerator, negative to the numerator. So we're going to go down 5, 1, 2, 3, 4, 5 over 3, 1, 2, 3, okay. And there's my line. Let me make this perfectly straight because I'm awesome. All right, just kidding. And there's my perfectly straight line. All right. Now, this one you need to be kind of precise on, right? Because when we do the next line, we're going to see where do they touch, and that's your answer. Wherever they touch will be your answer. So negative 3 is going to be right here. All right, and then we're going to go up 1 over 3. All right. Ooh, this one's easy because it even shows you where they connect right there. And draw that line. And then now you have to tell me where those two lines connect and where is it if we go over 3 down 2. So the final answer to this is 3, negative 2. Okay. Now I wanted you to just kind of pay attention to this. Obviously, I'm not saying take your notebook out and write all this down, but I do want you to get your notebook out in a second just to take some notes when we go over the Desmos, okay? So if we're going to do this one, I want to show you another way this could look. On the Desmos, it's going to show it this way. And it's not always going to be y and x on the Desmos. It's going to be d for distance and t for time. And you may see this in science a lot too. But instead of y and x, it's going to be the same idea. Y and then your x is here. And they're even going to throw it another way too. They're going to also look at this equation. It says y equals 4x plus 3. Sometimes it might even look like this. Y equals 3 plus 4x. And we're not going to let that mess with us. We still know that's our y-intercept, okay? And we know this is our slope. It's 4 over 1 is actually the slope, okay? So when we deal with this on the actual Desmos, it might say d equals, for one of them that gets a head start. I'll tell you what I mean in a second. It's like 6 plus like 1t, okay? And it's just the same thing that you would write if it was like this, d equals 1t plus 6. They're both the same thing. And I don't want to mess with you too much because you're going to be like, Mr. Bruce, I don't know what we're talking about. But again, you've learned all of this before, so you're going to let your brain go back into that mode of right before Christmas break, all right before winter break. Now we have positive 3. Now the tricky thing here for this one is we're supposed to go up 4, 1, 2, 3, 4 over 1. But that's way off the graph, and we want to be super precise. And I'll still put a point here because that's kind of where it would be. But instead of going up 4 over 1, I can go down 4, 1, 2, 3, 4 to the left 1. I'm allowed to do it that way, okay? And again, I'm going to pull out the ruler, and it still stays consistent. Right? That line is still consistent. I actually drew a pretty good point there. Now, let's do one more. Negative 2. I'm going to do a different color. Negative 2. I start here. That's my y-intercept. We went all over this last week. Down 1, right? That's a 1 in front of the x. I know I made that big. Down 1 to the right 1. Okay, and if we keep this pattern going, down 1 to the right 1, down 1 to the right 1, right? Isn't that the stairwell? Isn't that the pattern? So if it's down 1 to the right 1, could I go up 1 to the left 1? Up 1 to the left 1? Isn't that the same pattern? And it's pretty easy to see where they touch, okay? So you look at your pattern here, and we're good to go. Draw a line. Ooh, that's clean. I love it. Now, where's the answer? Pretty easy to see where they touch. You're going to be, it's a worst arrow I've ever drawn. Okay. To the left 1, do you see it? To the left 1 and down 1. And that's where it's going to be. Negative 1, negative 1. Right? And that would be your answer. Okay. And we're going to talk more about what that means, negative 1, negative 1. If you plug in negative 1 for x, and -1 for y, it's going to work for both these equations. If we put in here -1 times 4 is -4. -4 plus 3, that would equal -1. That would be the y. Okay. Now, I want you to have a notebook out to take some notes on what we're going to do from now on. Let me go ahead and do this here. I'm going to open this screen up and pause. All right, so this is the first page on the Desmos that I want you to do, and it says tell a story. And then you're going to go ahead and push play. All right, and you got these little turtles running, and you got one turtle, and I want you just to notice, then write a story about what you see. And I want you to be as descriptive as you can. You can even take notes now because you're going to fill this Desmos out later. So you could even write slide 1. You see slide 1 up here of 9. There's only 9 slides. I need to see you write some work. This is your credit for the day. All right. So right away, you should notice something. Obviously, lane 2 is booking it, and lane 1 is a little slower. But if I stopped it right here, you should notice some stuff about what's going on. Okay, interesting. You're going to explain it. I'm not going to be telling you all the answers on this one. But just understand and explain as much as you can about what you notice about lane 1 versus lane 2. Okay, next slide. Now you might get a little confused. It's okay, but you just need to take your time and take it slow. Now, if I'm looking at this here, I'm going to go full screen so I can draw on this a little bit too, so you can see what I'm talking about. If I'm looking at this picture again, if I'm looking at the graph, okay, time versus seconds, 0, 1, 2, 3. Okay, that's easy to understand. Lane 1, you just have to look at it. Okay, just take your time, take a breath. I know there's a lot to look at here, but it's not that difficult. Time. Okay, that's just measuring the time in seconds, and that seconds is up here too. Okay. Lane 1, red turtle in feet. So at 0 seconds, lane 1, the red turtle is already at 6 feet at 0 seconds. Interesting. Okay. Where is lane 2? Where's the blue turtle at 0 seconds? 0 feet. And does that make sense when you look at these two? You should have written that out in your first slide as well. Okay. And then if you're going to look at lane 2, actually now here, you're going to have to look at after 2 seconds. Lane 1 turtle is at 8. Lane 2 turtle, where is he going to be at 2 seconds? And where is he going to be at 3 seconds? And I actually didn't need to pause on this one. I'm going to go back to the screen. I'm going to show you what I mean. So you can hit play. And I hit pause. And that's at 1.3 seconds. You may have to do it again. If I try to stop it, I went past it. So at 2 seconds, though, I wanted to stop it and see where was my blue turtle at how many feet, and where is my red turtle at how many feet. All right, I'm going to stop it at 3 seconds. Where is my blue and red turtle at? Okay. So kind of take your time looking at that and fill in the rest of this table. That's your part, and you can check your work. Okay. Next slide. What is lane 2's turtle's speed? And when I clicked here, this is very interesting. It says feet per second. Feet per 1 second. Okay. For lane 1's turtle speed, it's interesting because after 1 second, it went 1 foot. Didn't it go from 6 to 7? Okay. So for lane 2's went from 1 second, it went from 0 to 3. Okay. So just take a second, try to fill that one out. That's not that difficult. You can submit, and it's actually going to have you explain how many feet is it going per second. Okay. Next slide. As new turtle enters the race in lane 3, press play and watch the race, then continue to the next screen. All right. Lane 3. This turtle's not that fast, but you're going to have to talk about this, okay? After 8 seconds, it went 12 feet. 12 feet after 8 seconds, okay? This one's a little more intense now. Next screen. So now it wants you to go ahead and drag the line, because this is the line for the red turtle. This is the line for the blue turtle. And notice about the red turtle again. It got a head start, didn't it? And look where it is on the y-intercept. Make that connection. Where is lane 3 starting? Well, lane 2 started at 0. Where's lane 3 starting? At 0 as well. So you're going to grab this point and you're going to put it where you feel it needs to go. And for this one, I'll give you a little help. It says the turtle in lane 3 finishes the race in 8 seconds. That's a hint. Where is 8 seconds here? All right. Well, you're going to drag this up to eventually be 8 seconds. Okay. Give you a little hint there. All right. Which is faster, lane 1 turtle or lane 3 turtle? And explain. Is lane 1 faster or lane 3 faster? Talk about it. Let's see what you think, okay? Look at these points, okay? Lane 1 got a head start, but does that make it faster? Or is lane 2? Look at the slopes of these lines and try to explain to me which one is which. Write an equation. So this one was kind of tough. I showed you, this is the one I'm going to take a screenshot of. So I already talked to you about the equations and how they're going to be a little different. Look at this one right here. See how it's d equals 6 plus 1t? Well, that 6 means it got a head start. It's already at 6 feet before anything happens, all right? That's the head start. Did any of these other ones get head starts? No, they're at 0. So you could put plus 0 at the end of these equations, but that's redundant. You don't really need to do that, okay? So now, what would any equation you want to do? So I could write d equals 2t, and that would be fine, okay? And what if I did do that? Let's see here. Let me go back to this. And if I put d equals 2t, all of a sudden it puts up my little turtle here. Now, what if I wanted to mess around and give him a head start? Plus 3. Where is that now? What if I said plus 4, plus 5? Do you see how I'm giving him a head start before we even go? And then if I hit play, let's see if he wins it. Oh, he's booking it. He's already done. Okay? Play around with this. Do whatever speed, whatever you'd like to. All right? But again, I want you to go through this Desmos. All right, next slide. You're going to create your own turtle by racing. This one takes a little time to mess with. But if I wanted to start here and put a point here, and I actually took this color here, and I'm going to put a point up here. All right, actually, I'm going to take this, and I'm going to drag it up here, mess around with this, and it gave me a turtle, okay? And if I want to pick a blue turtle, you can start here at 0 if you want. You can do whatever you want. Just give me, now look right there. If I do that, oh, why didn't I do a point there? I think we need a turtle. Let's see. Where's my other turtle? Oh, okay, it is there. It just came up at the end, all right? I want you to give me different turtles. Now, these ones are interesting because I put them at the end at the same time. Ooh, they don't tell me who won first or second, which is interesting because they know they obviously tied. So I messed with it a little bit. Do it for all 4 turtles by hitting the colors, okay? And the last slide. It says, this graph shows a distance versus time relationship, lane 1 and lane 2. Here are their equations. We've already been messing with this. I talked about what that 6 meant and then made a head start. Select all the true statements for this one. At 12 seconds, the lane 1 turtle is distance 6 feet. Where would you put the 12? For lane 1, you would put it for the time. And you do 12 times 1 is 12 plus 6. That would be 18 feet. So that is not true. Okay, so just go ahead and read through those. Submit this Desmos. I think you can just actually go through them all, do all the slides, and then hit turn in. At the end, I believe if I make it an assignment, I'm not sure. I might just make it a material. And you just got to get signed in there, and I can see if you've done the work on the slides. Great job, guys.